All right, guys, so we're surging into the second half of chapter 2. We've talked about exponent rules, we've talked about how to add, subtract, multiply with polynomials, and we've introduced the idea of being able to predict end behavior of a polynomial function. And now it's time for us to get serious about actually graphing these things with real points. Not just a prediction of what it'll look like, but a real, accurate representation. Let's think on a more general scale about what it means to graph. You're choosing an x, you're plugging it in, you're finding out what happens, and the result is our y. Think of x as an input, y as an output. We typically will make like a chart, right? X is on one side, y is on the other. All right, I always say think of a function as a machine. Think of that old show, How It's Made, right? We have raw materials, that's our input, and then by the end, after a series of things have happened, it's been cubed, we've doubled it, we've subtracted 5, we've done all these things, right? Whatever the rules are of that particular polynomial function, and then we get our final product, our output. Right? So with polynomials, this might take a while, right? 2x to the fourth minus 5x to the third minus 4x plus 8 when x is equal to 3. I have to write the function. I have to substitute 3 for every x, which means I have to do 3 to the fourth times 2. And then I need to do minus 5 times 3 to the third, minus 4 times 3, plus 8. Right. That can take more time than maybe I'd care to admit to get through all that. All right. So what can we do to make this a little bit faster? All right, we're going to learn about synthetic substitution today. One thing that I clearly encourage here, all right? Be careful, or not be careful. I recommend, to color code your notes, because when you do, it just makes it a little bit easier to look at. All right, so let's go with the same thing that we were evaluating, okay? And what I'm going to do this time is I'm going to write the coefficients of each step in the order of their descending exponents. So 2x to the fourth, there's the 2. Negative 5x to the third, there's the negative 5. Notice, this is so important, you guys. 0x squared. There's no x squared in here. We include the 0. You cannot, each column represents one of the powers. And so if we skip one, we include the 0. Then negative 4x, then the constant term. What we'll do is we'll start by bringing down the first term, and then think of that old, like the original video game, Pong or whatever it is, right? Where I'm just going to bounce the 3 off of this, right? That's how I try to think of it, at least. I'm a visual learner, right? I bounce the 3 off the 2, and it becomes a 6, right? 3 times 2, it bounces off, and now I have 6. And now what do? I'm going to add this column together. Negative 5 plus 6 is 1. Then I got to bounce this off. 3 times 1, 3. 0 plus 3, 3. 3 times 3, 9. Negative 4 plus 9, 5. 3 times 5, 15. 8 plus 15, 23. So what happens there is I get the exact same result, but it's less steps. Okay? So like I just said, you got to include all aspects of the function. So now we could do this really accurately. We could figure out, okay, I know it's supposed to turn this many times. I know which direction it's supposed to be pointing in the end. And I can use synthetic evaluation to at least quickly put together 3, 4, 5 points, put those up there and say, well, I know it's supposed to wind through this. I know it's supposed to be heading in this direction. And you can have a really accurate picture, all right? Right? You could do something like this by being able to predict, well, I know it's to the third degree, so it's got to be having alternate end behavior. I see a negative leading coefficient, so I know that that means that as I go towards negative infinity, I'll be going up. As I go towards positive infinity, I'll be going down. And then I can just quickly cycle through 1, 2, 3, 4, 5 points, right? Negative 2, negative 1, 0, 1, 2. Points that we are used to doing. And look at that. I have one that's up here, one that's down here, one right here, one right here, one right here. I'd be able to pretty quickly say, well, since I know it's supposed to turn twice, I'm supposed to be going up this way, so I'll come down this way And then I can see I clearly wind up going back up. Okay, so there's my first turn. Oh, and then look at this. I go back down. Oh, there's my second turn. And that's a really accurate picture you've got there. All right, we're going to practice this for several days. Okay. Work on looking at something like this, saying, what can I predict it to look like? And can I go back and use this method that I'm learning now that'll take some time to get used to? Practice, practice, practice. And can I put together a really accurate picture? Okay, something like this. All right. I hope this helps. I hope it's good to be able to look back at this video. Like I said, we'll work on this for several days. So if you're watching this video going, oh no, we have a lot of time to get comfortable with this.